Okay, welcome to the next lesson dealing with trigonometry. Now we're going to get into something new here. If you took 10 academic, you've already seen these next two lessons. There's sine law and cosine law. If you're coming from 10 applied, this is your first introduction to it. So what it is we need to be able to use primary trig ratios in triangles other than 90 degrees. So if you notice, SOHCAHTOA are called primary trig ratios because they work in 90 degree or right angle triangles. So what about if we don't have a right angle triangle? Like the triangle that's given to you here. There's no 90 degrees. You can see that, right? There's no little box inside one of the corners. So then we have to come up with something different. So our methods for solving for side length or angle inside of these acute or obtuse triangles would be that we come up with a ratio to solve. So in order to do that, we've got this formula over here, and it says that the sine law formula is A over sine A equals B over sine B equals C over... Okay, what that simply means is that you're going to put the side length over the matching angle. So how do I know what side length matches to what angle? This is the way that it's done. Your angle matches to the side length opposite of it. So if I want to find angle C, side length C is across. If I want to find A, side length A, angle A is across from side length A. The same is true for B. So all we're basically doing is that we're matching up a side length and an angle. And then I'll teach you the trick with sine law. So now, if I look at the first question here, it's asking me to find angle C. So first of all, what I'm going to do is circle matching side lengths and angles. I can even circle A here. Now I'm going to get rid of one of the matches that I've made. I don't need all three. A, I don't know what the angle is for A. And I don't know what the side length is for A. It's no good. It's not even asking me for A, for any angle or side length, so get rid of it. And now if we go back and look at our formula, it's going to be the side length over the angle. So side length over angle equals side length over angle. So let's come up with first the pair where you know both the side length and the angle. So if I look at angle C, I don't know what it is, but I know that its length is 40. For B though, I know that the angle is 55 and the side length is 50. So that's called my known ratio. It's setting up a proportion there. So I'm going to say that the side length is 50 and its matching angle is sine 55. So you see how I came up with that ratio of side length over angle? So the side length over angle is equal to the side length over angle. But do you know what the angle is for C? No. So we're just going to write in sine C. And now, going back to SOHCAHTOA, we're just going to cross multiply. Sine 55 times 40 is sine 55 times 40. Sine C times 50 is sine C times 50. So how are we going to get rid of this 50? What did we do before when we had our ratio? We would divide. We're going to do the same thing. So now on our calculators here, we've got this sine C is equal to sine 55 times 40 divided by 50. But wait a minute. What's this sine C tell me? Think back to primary trig ratios. Every time you were asked to solve for an angle, what was special about those questions? That's right. You had to press that shift or second function button. So now, there's multiple ways of doing this. If you have a two-line calculator, this is the easiest way to do it. So follow along because you have to be able to do this on your calculator. You're going to type in sine 55. That's the top, right? Sine 55. Press equal. Let your calculator tell you what sine 55 is. It's 0.81915, yada, yada, yada. Now, what do you have to do with that number? You have to multiply it by 40. So tell your calculator, hey, take that 0.81, now times 40, then press equal. Now your calculator has this number, 32.76. Now tell your calculator, what do I want to do? I want to divide it by 50. Tell it to divide it by 50. And now you've got this weird decimal, right? You see that decimal, 0.65532? Well, that's because you need to press the shift second function button for that decimal. I'm just going to write it down so you can see it, what it looks like. 6553, that's good enough. I'm not going to write any more. And now I'm going to shift second function sine that number and press equal on my calculator, and I'll get 40.9 or 41 degrees. That's how we're going to do it. This is a completely new lesson for a lot of us, but it's ultimately the same idea. If you're solving for an angle, guess what? You're going to have to use that shift button. If you're solving for a side length, we'll see what happens there, but it's going to be just cross multiplication with division. Okay, so let's look at another example here, since this is our first time for a lot of us seeing it. Let's match up our angle with our side length. Let's match up our angle with our side length. I don't care about A, and let's start filling it in. So again, the ratio is side length over angle. So side length over angle. And I'm always going to put my known pair first, so where I know both the side length and the angle. I like that, just for format. Then my side length is 15, and my angle is, who knows, sine C. We're going to cross multiply. Sine 72 times 15 is sine 72 times 15. Sine 18 times C is sine C times 18. Get rid of the 18 by division. Good, it's gone. Then we can type that into our calculator. Sine 72 equals times 15 equals divided by 18 equals, and we get this decimal number, and then we're going to second function sine that decimal number to get an angle of 52 degrees. So this is how we're going to be able to solve for angles using sine law. That's it. You see how the two examples are exactly the same? It can't change from that. So you got to get used to it. You're going to practice it, but ultimately you're multiplying, you're cross-multiplying, you get rid of, you isolate for that variable, the angle that you're trying to solve for, and then you press that shift button. So now let's see what happens when we need to solve for a side length. So that means I'm going to give you both the angles. So again, we'll use our technique. We'll match up a side length and angle, match up a side length and angle. Do you care about C and side length C? No, because it's got no information there. It's useless to me. So we're going to do the same thing. We're going to set it up with our side length, 30, over the angle, sine 65. We're going to set up the side length. Do you know what the side length is for A? I don't. It just says A. So that's what I'm going to write. But I do know what the angle is. It's sine 39. Now we're going to cross multiply. Sine 65 times A is sine 65 times A. 30 times sine 39 is sine 39 times 30. Here's your variable, A. How do you get rid of how do you isolate for that variable? Take what's in front and divide. Remember when I showed you before with the 10 equals 2A and how we got rid of the 2 by dividing? It's the same idea here. So we divide by sine 65 on both sides. This is the exact same method from primary trig ratios. That's why a lot of students love sine law, because it's the same. It's easy. You match up a side length over its angle, you cross multiply, and then divide. So now on this side over here, we're just going to do the math. So on your calculator, are we going to be pressing inverse or second function button? No, because we're asking for a side length, and we've never pressed that for a side length. When do we use that second function or shift button? Only with an angle. So you're going to use your calculator. Sine 39 equals. Let it tell you what the number is, so that way you get used to it. Sine 39 is a number. It's an ugly number. 0.62932, yada, yada, yada. Take that number and multiply it by 30 on your calculator. Now you've got the numerator, which is 18.8. Then tell your calculator, you know what? I want that numerator, and I want you to divide it by the denominator, which is sine, regular sine, don't put inverse. So sine 65. Press equal. Should get an answer of 20.8 or 21. That's the side length, and that's the only way that you can do it. There's no other way of solving for it in these right angle or 90-degree triangles. So we'll see it one more time here. We'll practice. Let's practice solving for E. And D here will match up, and F will match up. Oh, that's something weird, eh? If I look at this, it's asking me to solve for side length E. It gives me the angle. D gives me the length, but is there an angle listed for D? No. But F's got an angle, but no side length. Does it want me to solve for this side length over here, this F? No, it doesn't want me to solve for that. So why is it giving me that angle of 72? Because it's trying to make you do one extra step, which is that all interior angles of a triangle are 180 degrees. So you've already used up, we can see here, you've used up 49, you've used up 72. So how do I solve for this missing angle? You've just subtract. So 180 minus 49 minus 72 will give me that angle D that I need in order to move forward with sine law. Turns out that it's 59 degrees. Now that I know that this is 59 degrees, I can set up my side length over my angle. My side length over my angle. Because it's asking me to solve for that indicated side length, which is E. We'll do the same steps that we did before. You can see it right next to it. We're going to do sine 59 times E, sine 49 times 57. How do we get that E by itself? Divide by sine 59. We do that on the left and on the right. Now that it's gone on the left, E is whatever this is in our calculator. Let's solve now. So sine 49 equals times 57 equals divided by sine 59. I'm doing it on my calculator too to make sure that everything's working out, that everything's legit here. And you should get 50 meters. So that's how we're going to be using sine law. And again, just like before, we want to be able to do the overall expectation. So right now, I'm worried about giving you triangles and you using sine law to solve for. You can see that the next examples that are going to be given to you are you drawing your own triangles. Drawing your own triangles is an overall expectation because it's not a word problem. All it's telling you to do is to draw a triangle, label it, and solve. So let's see an example of that happening. Apparently we've got a triangle. So I'm going to draw a triangle. It's not a right angle triangle, but I know it's got vertices A, B, C. That's what it's saying here. You've got a triangle A, B, C. And here's what you're given. You're given that angle B is 57. You're given that angle C is 72. Then you're given that side length B is 18. How do you put in side length B? Well, it's across. It's opposite to the angle. So this is side length B. And it wants me to solve for side length A. This is what's marked. How can I solve for side length A without its angle? I need its angle because the ratio is side length over angle. So what step do I need to do first? That's right. In order to solve for that missing angle, I have to do 180 minus 57 minus 72 to solve for side length A, which now I know, or sorry, angle A, which now I know is 51 degrees. Now that I have that 51, this matches, I can solve. Do I care about solving for side length C? No. It didn't ask me to solve for side length C. I could if I wanted to have some fun, but I'm not that interested right now. So we'll set up our ratio. 18 over sine 57. A over sine 51. Cross multiply sine 57 times A, sine 51 times 18. What's our next step? Divide by sine 57. To clarify one more time, are we using inverse ever when we're solving for a side length? No. So no second function button, no sine to the power of -1, just regular sine. So on your calculator, regular sine, 51 times, so press equal, it's 0.77 times 18 equals, you get 13.98 divided by sine 57 equals 16.6. And that's how long side length A is. Now I want you to go forward and practice B and C on your own and look at the examples that I've given you written out. Anything that deals with word problems, we're not going to be doing in this unit. So drawing out a triangle is still fair game because that isn't a word problem. Word problems are like the one below here, or solving for the entire perimeter for a garden bed. We're not going to be doing these types of questions, although we could. These thinking questions. We're not going to worry about them right now. So basically what you need to know for is the information that's given below, that's when you can use sine law. So I can use sine law when I have a matching angle and side length. When I have a matching angle and side length, that means that I can use sine law. So I've got a matching angle and matching side length, and then I can solve for a side length. Now, what about if I don't have a matching angle or side length? Well, I have to. So if I'm given two angles there, that means I'm going to use that rule of 180 to be able to solve for that angle to have a matching angle and side length, because I need to. I need to have that proportion. So you can use it when you're given two side lengths and an opposite angle, or when you're given two side lengths and two angles and any side, because the third angle you can always solve for. That concludes the lesson on sine law.